The San Antonio-class amphibious transport docks, formerly known as the LPD-17 class, represents a milestone in U.S. amphibious warfare capabilities, designed to replace multiple older classes of amphibious warships, including the Austin-class LPDs, Newport-class tank landing ships, Charleston-class amphibious cargo ships, and the Whidbey Island-class dock landing ships. These vessels embody the Navy and the Marine Corps' vision for modern and survivable expeditionary platforms. The class is intended not only to transport and land Marines, but also to provide command and control capabilities, support aviation operations, and serve as flexible forward-deployed sea bases for a variety of missions. The program originally proposed 12 ships, with an initial target cost of $890 million per ship. However, as with many defense acquisition programs, the final cost for the Flight 1 vessels exceeded estimates, and we will get into that later. The US Navy subsequently expanded the plan to produce a second flight of 13 LPDs, known as Flight 2, bringing the total to 26 ships. These Flight 2 ships incorporate lessons learned from the first generation, as well as design simplifications intended to improve affordability and operational effectiveness. As we shall see, despite efforts to keep construction costs under control, the price tag have continued to increase. Construction on the lead ship, the USS San Antonio, began in the year 2000, with delivery in 2005. Since then, 13 ships have been commissioned, including notable vessels such as the USS New York, USS Arlington, and USS Somerset, which use steel salvaged from a certain tragic event that I will not go into here. The USS Fort Lauderdale and USS Richard M. McCool Jr., the 12th and 13th ships respectively, introduced transitional design features that bridge Flight 1 and Flight 2, including changes to the mast structure and radar systems. The first Flight 2 ships, USS Harrisburg, is currently under construction, with additional ships contracted and under development. At 208 meters in length, with a beam of 32 meters, and a full load displacement of approximately 25,300 tons, the San Antonio class is over 45% larger than the Austin-class vessels it replaced. Despite this increase in size, the ships carry fewer troops, typically accommodating up to 700 embarked Marines with a surge capacity of 800. This reduction in personnel is offset by a substantial increase in vehicle, landing craft, and aircraft capacity, reflecting a modern focus on mobility and flexibility rather than purely manpower. Propulsion for the San Antonio class comes from 4 sequentially turbocharged marine diesel engines driving 2 shafts, producing a total of 41,600 shaft horsepower and enabling speeds in excess of 22 knots. These ships are designed to support a wide variety of amphibious operations, with well decks capable of handling 2 air-cushioned landing craft, 1 smaller utility landing craft, and up to 14 amphibious assault vehicles. In addition, they feature flight decks and hangar facilities capable of operating MV-22 Osprey tilt-rotor aircraft, CH-53E helicopters, or a combination of other rotary wing aircraft. The San Antonio class was built using a design for ownership approach, which means the Navy involved the people who would actually use, maintain, and train on the ships right from the start of the design process. By getting feedback from future operators and crew members early, the Navy was able to make the ships easier to operate, more comfortable for sailors and Marines, and more effective in long deployments and in combat. This approach also helped improve the ship's systems, survivability, and overall performance, while keeping long-term cost under control. The San Antonio class prioritizes quality of life for the crew and embarked Marines. Ships feature sit-up berths, a ship services mall, a learning resource center, a fitness center, and medical facilities, including 2 operating rooms and 124 beds. They are designed to accommodate mixed-gender crews and embarked forces, reflecting modern personnel standards and operational realities. Survivability is a central aspect of the San Antonio class design. These ships incorporate improved nuclear blast and fragmentation protection, shock-hardened structures, and reduced radar cross-section techniques to make them more difficult to detect and target. Defensive systems include 2 30mm Bushmaster 2 guns, 2 rolling airframe missile launchers, and multiple 50 caliber machine guns. The ships are also equipped with integrated ship self-defense system, which fuses radar and sensor data to automate air defense reactions. One of the San Antonio class's biggest strengths is its advanced sensors and onboard network. The ship are built around a fiber optic network that links all of the ship's systems together, making it easier to upgrade equipment or replace hardware when new technology becomes available. Early ships in the class used reliable radars like the AN-SPS-48G and AN-SPQ-9B to track aircraft and surface threat. Newer ships, including the USS Richard M. McCool Jr., have been fitted with the much more advanced Enterprise Air Surveillance Radar, known as the AN-SPY-6 V2. This radar uses a modern electronic scanning system that allows the ship to detect and track targets more accurately, even in areas where electronic jamming or other countermeasures might be used. It gives the crew a clearer picture of what's happening around the ship, helping them make faster, better decisions. Overall, the combination of this high-tech radar and the ship's integrated network makes the San Antonio class much more capable at operating in contested environments. One of the most innovative features of the San Antonio class is its well deck. This floodable space allows the launch and recovery of air-cushioned landing craft, utility landing craft, and amphibious assault vehicles, facilitating rapid and flexible deployment of troops and vehicles directly onto contested shorelines. The well deck can also support future operations, such as deploying large uncrewed underwater vehicles. Combined with the flight deck and hangar facilities, this makes the LPD a versatile platform for both amphibious assault and secondary aviation operations. Operationally, the San Antonio class LPDs provide substantial force projection capabilities. They can transport and land Marines and equipment across significant distances, making them essential assets in regions like the Western Pacific, where potential conflicts could require the rapid deployment of expeditionary forces. The ship's integrated command, control, communications, computers, and intelligence systems allow them to function as mobile command centers, coordinating operations across multiple domains and branches of the armed forces. The class has not been without challenges. Early ships experienced design complications and construction delays, with the Department of Defense's Operational Test and Evaluation Office reporting that the initial lead ship, USS San Antonio, had deficiencies affecting operational effectiveness and survivability in combat conditions. These issues have been largely addressed in later ships, with transitional and Flight 2 vessels benefiting from improved construction techniques, updated radar and sensor suites, and lessons learned from early operational experience. A significant aspect of the program is the ongoing Flight 2 development. These ships are designed to replace the aging Whidbey Island-class dock landing ships and the Harper's Ferry-class amphibious warfare ships. Flight 2 vessels incorporate over 200 individual changes compared to Flight 1, including a simplified bow, modified stern gates, traditional steel mast replacing composite structures, and upgrades to flight decks and hangar arrangements. The class retains its core amphibious capabilities while integrating design changes aimed at improving affordability and maintainability. One of the most visible changes for the upcoming Flight 2 ships is the redesign of the radar mast. Earlier ships in the class had two all-enclosed composite masts that gave them a distinctive, futuristic appearance. These masts were made of advanced composite materials, the largest ever installed on a steel-hulled ship, and were designed to reduce the ship's radar signature and improve stealth. On the USS Richard M. McCool Jr. and going forward with Flight 2 ships, the stealthy mast had been replaced with more traditional steel mast. The new design is simpler, more conventional, and easier to build and to maintain. While the sleek composite mast were visually striking and helped lower the ship's detectability, they were costly, complex, and presented maintenance challenges. Switching to steel mast allows the Navy to save money, speed up construction, and reduce long-term upkeep, all the while supporting the ship's advanced radar and communication systems. There are trade-offs with this change. The traditional steel mast slightly increased the ship's radar profile, making it less stealthy than earlier Flight 1 ships. However, this is offset by the installation of this new Enterprise Air Surveillance Radar, which provides far greater detection, tracking, and situational awareness capabilities than the older radar systems. The new radar system is mounted on a rotating base towards the stern of the ship, allowing the San Antonio class to detect air and missile threats at longer ranges, even in environments with electronic warfare interference. In practice, this means that while the ship may be marginally more visible to radar, its ability to monitor and respond to threats is vastly improved. The change reflects a broader shift in US Navy design philosophy, prioritizing capability, reliability, and cost-effectiveness over low observable features, particularly for ships like amphibious transports that operate as mobile sea bases rather than frontline combatants. This all points to the US Navy backing away from stealth as a top priority in future ship designs, especially in order to save money. From a strategic perspective, these LPDs are essential force multipliers. By serving as sea-based platforms for amphibious operations, they allow the Navy to project power without relying on host nation bases or pre-positioned infrastructure. In scenarios such as disaster relief, humanitarian assistance, or conflicts, the San Antonio class provide a mobile base from which Marines can conduct operations with speed, flexibility, and resilience. The class has also been envisioned as a potential platform for joint and combined expeditionary operations with other US Navy ships, Marine units, and allied forces. In a complex operational environment, this capability allows the San Antonio class to function not only as a transport and landing platform, but also as a forward-deployed command hub capable of integrating intelligence, surveillance, and reconnaissance inputs into operational planning and execution. In addition to the amphibious and expeditionary roles, San Antonio-class LPDs are designed with adaptability in mind. The modularity of their systems, combined with the plug-in and fight network architecture, allows for relatively straightforward integration of new technologies over the ship's life cycle. Concepts such as the potential installation of vertical launch missile systems illustrate the class' ability to adapt to evolving threats and missions, enhancing both defensive and offensive capabilities. Despite its capabilities, the Navy currently lacks sufficient numbers of San Antonio-class LPDs to fully meet strategic needs. The vast distances of the Pacific, combined with potential conflict scenarios, require multiple amphibious ships operating in dispersed formations. While the Navy has committed to producing Flight II ships, budgetary and cost pressures have led to strategic pauses in acquisition, raising concerns about whether the service will achieve the desired fleet size. Cost is a critical factor in the San Antonio-class program. Flight I ships averaged around $1.6 billion each, representing the fully loaded acquisition cost, which includes design, construction, shipyard labor, equipment, weapon systems, sensors, and initial spares. As I discussed, this average price tag of $1.6 billion is much higher than the original targeted estimate of $890 million per ship. Flight II ships, which incorporates numerous design improvements, simplified structures, and upgraded systems such as the Enterprise Air Surveillance Radar, have seen per-ship cost rise to between $1.62 billion and $2 billion. The upper end of this range reflects fully outfitted vessels, including advanced electronics, combat systems, shipboard network upgrades, and inflation-adjusted material and labor cost. Factors such as global supply chain pressures, steel and composites material prices, and workforce shortages have further contributed to these increases. These rising costs have prompted discussions within the Navy and Congress about the potential benefits of multi-ship contracts or block buys, which could lock in pricing and reduce per-ship expenses. Despite these financial challenges, the Navy continues to invest in the program, recognizing that the $2 billion expenditure represents not just the hull, but a complete, fully mission-capable amphibious platform capable of projecting power, supporting Marines, and serving as a forward-deployed command hub for decades. The naming of several ships in the class underscores their symbolic and cultural significance. USS New York incorporates steel salvaged from the site of that terrible event in New York City, while USS Arlington and USS Somerset honor victims of related attacks. USS Richard M. McCool Jr. commemorates a Medal of Honor recipient who displayed heroism during the Battle of Okinawa. Such designations link the class to national history and underscore the U.S. Navy's commitment to honoring past sacrifices. In conclusion, the San Antonio-class amphibious transport docks represent a substantial evolution in U.S. amphibious warfare capabilities. They combine advanced survivability, sophisticated sensor and network systems, and versatile well deck and aviation capabilities to support a wide range of operations. From disaster relief to high-end conflict scenarios, these LPDs provide the Navy and the Marine Corps with mobile and resilient platforms capable of projecting power globally. While early design and construction challenges highlighted the difficulties inherent in modern warship programs, subsequent ships and the ongoing Flight II developments demonstrates the Navy's commitment to learning from experience and enhancing operational effectiveness. Rising cost and limited fleet numbers remain challenges. but the operational value and flexibility ensure that the San Antonio-class LPD will remain central to U.S. naval operations for decades to come.